Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas?
Why do some things glow in the dark?
Why do animals not understand humans? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello, welcome to this week's edition of Ask the Naked Scientists with Dave Ansell and with me, Matt Jamison.
To the emails we go then. Nicholas French has sent one in. It says, why does water make roads slippery, but pages easier to turn? And I'm not a scientist, but that's not strictly true, is it? Because you use saliva.
It would work with water as well.
Oh, would it? Oh, okay.
I'll
just be here when you need me.
I think saliva probably does work better because there are a load of sticky proteins in there. But water will work. It tends to make your fingers a bit sticky. If you just put some water on your fingers, it'll pick up really light things. Essentially, it's a matter of scale. If you're on a really big scale, then water essentially acts as a lubricant. If you've got sort of maybe a millimetre of water between your wheels and the road, then water's quite slippery. It's a liquid. If you push it, it won't resist the force, so it lubricates you, and you lose grip and you crash into things if you're driving. But on a really, really small scale, especially if the water isn't continuous, if you just got a blob of water, then you get this effect called surface tension. This is water molecules attracted to other water molecules, and they're also attracted to your fingers, and they're also attracted to paper. So this is the reason why water goes into globules, because all the water molecules are attracted to each other. They try and get as small as possible, and the shape which has got the smallest surface area for its volume is a sphere. So small amounts of water tries to form little globules, little spheres. And so if you've got some water on your finger and you touch a piece of paper, and the surface tension, the water will stick to the paper, stick to your finger, and so you can pick it up. But if you've got lots of water all over the place, it won't cause things to stick together. And if you've got a big distance of it, acts as a lubricant, a bit like oil, and you slide off the road.
Very good, very good. If you have a question for the Naked Scientists, of course, they always have tons of questions, but they're always happy to answer yours. Got a couple of questions from the big news stories of the day, and this is something that I've been fascinated by as well. What is static shock? How is it caused, and how can we prevent it? My experience of this is when you go too close to someone who's charged, and you get a little kick off them.
You get a little kick, yeah.
Yeah, that can be really painful.
Or if you rub, it's the same effect if you rub a balloon on your hair. It charges up, and then you can stick it to walls. Mostly the reason why you charge up, or in fact the reason why when you rub a balloon on your hair it charges up as well, is that different materials like electrons, an atom's made up of a nucleus and little electrons orbiting around it. Different atoms like electrons, different amounts. It's different materials. So if rubber, for example, likes electrons more than hair does. So whenever you touch a piece of rubber onto your hair, a few electrons get moved over onto the rubber. As you rub it, you keep touching it in different places, so more and more electrons get moved onto the balloon, and the balloon gains more and more electrons and it becomes negatively charged. Because you're losing them, you become positively charged. The same thing if you walk over a carpet. If the carpet's made of different materials, your shoes...
School carpets normally, isn't it?
Quite often.
School carpets. They used to make school carpets out of something different to what they made other carpets from, and it used to really hurt.
You were traumatised by this, weren't you?
High-five someone and end up at the other side of the room. But there we are.
Yeah, and then if you charge up, then if you touch something which is attached to Earth, so a piece of metal, which is like plumbing or doorknob, or quite often I find it in Marks and Spencer's in Cambridge, you walk across the floor, reach the railings to walk up the stairs, and you touch the handhold, and you get a big shock off it, because then all that charge is built up when you want to escape, get back to Earth, it will run through your finger just as you touch the metal. You then get an electric current running through you, and that's what you feel.
Now, if you are making that electric current when you touch the metal, for that split second you get that kick, is that whole thing live? Or is it just earthing?
Well, if it's attached to Earth, then it's not going to be live. It's not going to change the voltage very much because it's a tiny, tiny current, microamps, if not nanoamps. And so it won't actually change the voltage. If you could touch somebody else who's holding on to something Earth, and then the current would flow through them, and then they get a shock as well.
You had a question about this on Sunday, didn't you?
Yes.
You had a question about this very same thing.
About tasers, yes.
Yes, that's right. If you were holding your girlfriend's hand, would you be tasered as well?
We think the answer's no. We haven't got an expert, or we haven't done the experiment.
Did you find out what part of Essex they're from? Because whether it's yes or no, you don't want to go there, do you?
It's kind of scary.
Yeah. Here's another question for you, Dr. Dave. Stand by. Are you ready? Are you coiled like a spring? Why is it that when your remote control is losing power, you can roll the batteries around with your finger and it works again? That's from Greg Turner in British Columbia.
I think there's a couple of things which might have something to do with it. One of them is that batteries are basically a chemical source of energy. They run on chemical reactions. And the hotter you get a chemical reaction, the faster it goes. So if there's still some energy left in them, if you heat them up, it'll release that energy quicker. So it will. So if it's just not, there's not quite enough power there, it's not releasing energy fast enough to run your remote control. You heat them up a bit, it will release what energy's left quicker. So you can just push it up above what you need in order to run the remote control, and it can run for a bit longer.
But not much longer.
Not much
longer. You're probably
longer.
better off just buying some new batteries.
Definitely. And the other thing you can do is if there's a slightly dodgy contact, if you get some grease or something between the contacts and the battery, or it sort of gets a bit oxidised, sort of equivalent of rust, but for different kinds of metals, if you kind of roll the batteries around, you can kind of work your way through that and you get a better connection and just push it up above the amount of energy you need, above the voltage you need to run the device.
Surely it's less time expensive just to buy some new batteries, isn't it?
Well, it's quite a long walk. The shops might be shut, especially if you live in the middle of nowhere.
But normally you'll find in that drawer where all men keep things like grease and Swarfiga and maps for IKEA and things like that, there's always a couple of spare batteries knocking around.
Yeah, but finding the ones which aren't already flat is
that is true.
If you're enjoying Ask the Naked Scientist, then you might like to check out The Naked Scientist, our regular roundup of the world's best science. Each week we take a look at the latest science news, talk to top researchers working at the coalface of discovery, and also get our hands dirty with a science experiment that you can join in with too. So make it a date and prepare to strip down science on the web at nakedscientist.com/podcast.
Got another question for Dr. Dave, who is in the studio, just looking very chilled and laid back and taking the questions like water off a duck's back and, just very relaxed, and we haven't flummoxed him yet. I must have been doing this a couple of times now. We still haven't got the question. He said, do you know what? I got a clue. I've got a clue how that started. We will do, though, one day, I'm sure.
I'm sure.
It'll be about something to do with Dire Straits. Dave in Dis has been on. He says, why in England do we have electricity current of 240 volts, whereas the rest of the world has 110 volts? Surely 110 would be cheaper to run than 240. Also, does this mean we're paying twice as much for electricity? I guess twice as much as the people who have 110.
The simple answer is no. Okay, what we mean by voltage is basically how hard the electrons are being pushed through a wire. So current's the number of them flowing through a wire, and voltage is how hard you're pushing them. And the amount of power which you get out is the voltage times the current. So you can get the same amount of power by doubling the voltage and halving the current, or if you halve the voltage and double the current, you'll get the same amount of power, so you'll be able to do the same amount of stuff with it. So it'll make the same amount of heat to heat up your dinner, or it will run a computer for the same amount of time. So all devices in America, although they're running at half the voltage, they run at twice the current. This is actually a disadvantage because the amount of energy you lose in a wire is proportional to the current, and it's got nothing to do with the voltage. So if you halve the voltage when you go over to the States, you'll have twice the current. So you lose twice as much energy just pushing the electricity around the wires. So in many ways, 240 volts is better. There are some disadvantages in that it's slightly easier to get electrocuted from 240 volts than 110. So it's
you say it was such sort of diploma. It's just like it's slightly easier to have your head blown off by 240 volts than it is 110.
Yeah, I mean,
yeah.
If you design it right, it's very difficult to get electrocuted anyway. But yes, I think that's part of the reason why the States are a bit less tight about all the electricity regulations. In fact, a lot of the world does use 240 volts. I know the whole of Europe does, or 230 volts technically these days. I know South Africa uses 230 volts. I don't know about the rest of the world. I haven't visited it yet.
When you do, can you make a note of their voltage for us?
I will. I'll get a big list.
Great stuff. Now we've got Tony on the line. He's got a question about sunspots. Hello, Tony.
Good evening, sir.
Whereabouts are you calling from tonight?
Westcliff.
Well, it's lovely to hear from you. How's the weather been in Westcliff today?
Very nice indeed. I've been in the garden working.
Is summer finally here, in your opinion, Tony?
It's on its way.
Oh, good news, good news. Well, listen, you're through to Dr. Dave. Asking me a question.
Right. I caught something on the tail end of a news item. I think it was about sunspots and how they affected things like computers, radio, telly, and all that sort of thing. I don't know. Could you tell me something about it? You know, I mean, it could really sort of muck them up completely.
Yes.
So they said.
Basically, sunspots are basic sort of magnetic storms on the sun. They're sort of an area of the surface of the sun which is slightly colder than the rest of it, so they're slightly less bright. So if you shouldn't look at the sun directly, but if you projected it on something, so you can see a picture of the sun, you see these little darker spots, and they're still very, very hot. They're still thousands and thousands of degrees centigrade, but they're slightly cooler than the rest of the sun, so they look darker. So they're called sunspots. Associated with these storms, you get these sort of what are called coronal mass ejections, these huge explosions in these storms which throw out a load of charged plasma, basically, which fly out into the solar system. If this collides with the Earth, then the first thing you get is you get really impressive northern lights, because you get charged particles flying, they follow the Earth's magnetic field, and they crash into the atmosphere at the north and south poles, where the Earth's magnetic field reaches the ground, crash into the atmosphere, give it lots of energy, and it starts to glow, so you get really cool glowing patterns in the sky. But also you get huge electric currents flying up in the moving in the upper atmosphere, and you get changing magnetic fields, and that can induce big currents in electricity grids. So you can get big DC, direct current electricity running around loops in electricity grids. This knocked out Canada's power supply sort of 10 or 15 years ago. So you've got big electric current flowing around a grid which is not designed for it, all overheats, it trips all the switches, or you melt, or even worse, you melt a transformer somewhere, and you can knock out power grids. All these charged particles can smash into satellites and do them direct damage. They can affect the ionosphere, which is a layer in the atmosphere which will reflect some radio signals. And so it can start reflecting radio signals in strange ways or not reflecting them, so shortwave radio reception gets really bad if you get hit by one of these solar storms. Yeah, they can generally cause chaos.
How about that, Tony?
Well, I just wondered if a little question. What about aeroplanes? Because they're full of computers and things. Would it affect them?
I guess it could affect them. The problem is these charged particles can go in. They can actually sort of reset the ones and zeros in computers. It's a big problem in satellites, even just normally, especially anything which goes out of low Earth orbit. And they've got to have all sorts of checking systems to make sure that none of their ones and zeros have been flipped over. So it could be a problem with aeroplanes. Certainly, this cosmic radiation does mean that you get exposed to a reasonable dose of radiation when you're flying in a plane. I've seen some calculations that when there's a lot of cosmic rays about, then pilots are getting more radiation than a nuclear worker would be legally allowed to in this country.
What about pacemakers? Could it affect them?
Again, it would depend on exactly how you design. It basically depends how you design the electronics. If basically the smaller the electronics gets, the more damage a single particle can do, the more sort of ones and zeros it can flip. The more damage it can do. You can certainly design electronics to make it impervious to this sort of thing, but it depends whether they have on pacemakers. I don't know how paranoid they were when they designed it.
Never heard of it.
Yeah, another interesting thing about sunspots is it seems that when there are lots of sunspots, the sun is the sun is hotter. So in a period when there's lots of sunspots, although the dark bits are cooler, the actual spots themselves are cooler, the rest of the sun is warm, the surface of the sun is warmer, so it gives out more heat, and that might affect our climate. There was a period called the Little Ice Age in the sort of 17th and 18th centuries, and there were almost no sunspots for sort of at least 100 years, and that associated with a period when you had like ice fairs on the Thames and things.
Oh, yeah.
An interesting piece of research recently is at the moment we've got far fewer sunspots than we expect. this normally runs on an 11-year cycle, and they drop off and build up and drop off. But so they seem to have dropped off. They're not building up quite as soon as people were expecting them to. So we're not sure whether they're going to build up again and it's nothing, or whether we might be going into a sort of quiet stage where the sun's a little bit cooler.
We'll have
Thank
to
you
wait
for calling,
till Friday,
Tony.
Doctor.
And I tell you what, let's just enjoy the sun while it's still with us, shall we?
Exactly.
Cheers now.
Thank you
Bye-bye.
very much,
Thanks ever
sir.
so much. And, of course, if you have a question for The Naked Scientists, you can email it in to...
Chris@thenakedscientist.com.
Why do my speakers hum when I press the speaker jack against my skin or hold it in my fingers? Can it hear the electricity my body gives off? That comes in from Leisha.
It's not really actually picking up the electricity your body itself is giving off. What it's picking up is essentially electricity in the walls around you. What you're hearing is a 50 hertz hum, or if you're in the States, a 60 hertz hum. This is from the mains. Essentially, you've got lots of wires. If you turn on a kettle or something, you get a big electric current flowing up and down the wires. And electric currents, because it's alternating current, it's flowing backwards and forwards and backwards and forwards. An electric current flowing backwards and forwards actually emits radio waves. So it's actually a sort of a big aerial which is transmitting radio waves at 50 or 60 hertz. And then if you've got your speaker, the reason why you've got two wires, well, you need two wires in it, is the two wires are picking up the same amount of these radio waves. But one of them in one direction, the other in the other direction, so they cancel it out and you don't actually pick up any signal. But if you essentially make one wire much longer than the other one by touching your finger onto the centre of it, then you act like an aerial. You pick up this 50 hertz radio waves, which all of your mains electricity is emitting. It then goes into your amplifier, and then that's amplified and put out onto your speakers, and you can hear it. And so you hear a hum at sort of 50 or 60 hertz.
It's very good. It's very good indeed. And if you want to... If you've got a speaker, is there any way, apart from sort of upgrading the sort of standard of your speaker, that you can make your speakers better? Because people have told me in the past, if you get better cable, you get a better sound.
Up to a certain state, if you have very, very, very cheap cable, I'm sure it does make the sound worse. Certainly, if you wire something wrong, then you can pick up lots of 50 hertz hum. You can start getting noise picked up and things. You can lose a lot of signal down the wires, and that means that there's the sort of natural noise. You get sort of electrons just wibbling around because they're warm, and you start hearing a hiss, very quiet hiss under things. I'm not entirely convinced by spend 5,000 quid on a piece of wire, because where they do all sorts of crazy things to wires. My major reason is that I'm not sure that they're doing as crazy things inside the actual amplifiers to make the wires absolutely perfect. So It's very, very unlikely that
you'll get a good amp and a good wire. Yeah,
you might have an absolutely perfect wire, but if there's something minutely dodgy in the amplifier, then it's going to completely overwhelm any effect from the wire. I'm suspicious of it, I think, fundamentally.
If you're suspicious of it, I ain't going near it. That's the law. But hopefully that's answered your question, Leisha. Maybe you like the sound that you get off holding a speaker cable. We suggest you plug it into the speaker. That's it for this week. Thanks for listening. Remember, you can send The Naked Scientists your questions by email. Chris@thenakedscientists.com is the address to write to. And if you want to find out more about The Naked Scientists, then drop by our website, nakedscientists.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.